My name is Unni Pillai, and I'm a solution architect with Amazon Web Services, focusing on big data and analytics. So today we had a bunch of sessions for you where we spoke about analytics services on AWS and how you can build data pipelines, data lakes, and how do you drive business value using analytics services on AWS. So in this session, I'm going to talk about, in the next 40 minutes, how can you build a data pipeline end-to-end, and build a data lake by the end of it. So before we get started with that, we need to understand why data lakes are important, and why we should be building them, and why you should be thinking about it from a business standpoint, and what are the business values that it gives you. So if you think about the way the amount of data has been growing, the velocity, the volume, and the variety of data that we are dealing with on a day-to-day basis is increasing. So that being said, you also need to have systems that will be able to cater to that kind of scale and cater to that kind of requirements that you have within your organizations. So a report that was done by IDC shows that the amount of data that companies are generating and companies are accumulating is increasing 10 times by every 5 years. And a usual lifetime of a data platform within an organization is usually for 15 years. So a data platform, when you build it, it lives in the company for 15 years. The tools that you use, the architecture that you have, might change, and it might evolve over a period of time, but whatever you build needs to be built to scale up to 1,000 times for the next. When you are in 15 years after, when you're 15 years from today, it needs to have the scale that is 1,000 times bigger than what it is today. That being said, you also have tools that have evolved over a period of time. We have 11 years back, Apache. There was an Apache project that came up called Apache Hadoop, where it made it easier for companies to do analytics, large-scale analytics. So it was definitely a step up from data warehousing, because in data warehousing, you had a bunch of servers, and you had data that was distributed across those servers, and you were able to run parallel queries. But the major problem with that was your architecture was very tightly coupled with the compute was very tightly coupled with the storage. And because of that, what happened was it became very difficult and very expensive to manage and run in a large scale. And Hadoop helped solve that problem. But if you look now, no matter what the problem is, people say that Spark is a solution for anything to do with big data. And over the last 4 years, Spark has become the de facto standard to do analytics workload. And because of that, you see most of the products today supporting Spark as an execution environment. The key thing to note is that whatever architecture that you build, I told you 15 years is when a usual data platform will live. And over that 15 years, if you look at, in this slide, we have showing last 11 years, what are the tools that came and went. And your platform would still be there. And the way you need to build your architecture, the way you need to build your data lake, would be in a way where you should be able to plug out tools that are no more useful and plug in tools that you want to replace them with. And doing this will help you innovate faster, because you'll be using the latest and the greatest tools available out there. So today we have Spark that is used for everything. But in the future, there might be some other tool that might replace Spark. So your architecture that you build should be built in a way where you're able to take out Spark and plug it in with another set of tools that are coming in. So people who are from machine learning background have done data science in the past. People used to do data science using R and Python and a bunch of other stuff. Python is still used today. R is still used today. But then over the last couple of years, MXNet has really taken over. TensorFlow has almost become a de facto standard for doing deep learning workloads. That being said, the way you should be architecting, you should be able to plug these tools in without massively re-architecting your application. So with that, let's take a look at a couple of things that people want or companies want from their data lake. 10 years back, if you would have asked a data professional, what is the purpose of building data platforms, they would have told you business intelligence use cases. That was pretty much the only thing that they did. So somebody from marketing, somebody from sales would tell them, hey, I want a report for this. The BI guy would go in, build a bunch of dashboards, and give it to the business users, and they would analyze data. But if you look at how data teams have been structured over the last few years, it has changed drastically. Now you have these primary 4 personas within every organization. You still have the BI user that does the reporting and dashboarding and visualization for things. But we have now data scientists, analysts, and application integrations that are happening. So application integrations could be your company sharing data with other company. An example of that would be your company's loyalty management system sharing data with its partners so that they can run joint promotions or joint sales activities. You still, and you have data scientists who require access to raw data or curated data based on the workloads that they're working on or use cases that they're working on. And when they want something like that, giving them a data warehouse is not going to help. So a data warehouse will give them access to data that is in a structured form that has been curated for them, and they will be very limited. They will feel very limited by that kind of data. So you need to give them a self-service platform where they have the ability to go in, scan the data that they have, look at the data that they want to use, and extract the data out and do the analysis on top of it and build their models. So the personas, each of these personas in an environment would be, the requirements for them would be very different. So what a data scientist needs is probably a notebook environment and a self-service analytics tool. What a BI user needs is a data warehouse, a BI tool, and querying capability where they can go and explore data and build dashboards. Whereas application would need APIs and SDKs that you should be able to connect to, and they should be able to share information with each other. And while you need to cater to these personas, you also need to make sure that these users are able to access it securely. There is a proper governance structure in place so that people who do not have access to, people who should not have access to things, do not have access to that. While all of this is being done, you also need to think about how I'm going to bring in fast-moving data that is coming in very high velocity and high volume. How do you ingest that data? So that is your real-time systems. How do you ingest your real-time data into the platform, and how do you make it available to the users to consume? So being able to do real-time predictions, being able to do alerting on data that is coming in, and analytics around it. And while scalability is the biggest thing that you should be focusing on when building a data lake. So how are you going to make something that is going to be scalable and doesn't increase the cost in a linear way when the amount of volume or the amount of data increases? So if you think about the textbook definition of data lake, this is what I think a data lake should actually mean. So it's an architecture approach that allows you to store massive amount of data in a central location. And when you store that data in a central location, you should create mechanisms within the platform to be able to cater, to be able to serve multiple set of users, be it data scientists, be it BI users, or be it application users, from a single place. So common use cases that we see around data lakes are people wanting to do advanced analytics. So they say, I have data coming in from system A, I have data coming in from system B, and now I want to combine these two data and do some intelligent analytics around it. So that's why we see. Those are some of the examples that we see. And the data usually comes in from two places. If you have an on-premise infrastructure, you would build data ingestion tools or use data ingestion tools that are available out there to bring the data or push the data to a data lake and do analytics there. While you also need to combine that data with the real-time ingestion that is happening. So you need to combine the data with the real-time data that is coming in. So these are things that you need to focus on when building a data lake. So characteristics of a data lake are a few things that you need to focus on is it should be able to work with relational data sets and non-relational data sets. So things like structured data and unstructured data. You should not be locking yourself into a particular technology. Like some of the database vendors, when you buy the product, you pretty much feel locked in. So you should not be building it in a way where you get locked in into the technology. And everything will be cool when you build a data lake, but then if the cost is not low, somebody from your finance team would come in and ask you to shut that down. So you need to also be cost cognizant and make sure that whatever you build is built for scale, is built for cost and scale. So customers have been building data lakes on AWS from the very beginning. So the largest customers that we have on the platform have built their data lakes on AWS, likes of NASDAQ, FINRA. In the region, we have iFlix. Today, in Renee's session, you heard from FWD on how they built their data lake on AWS. Yuha was here talking with NTUC on how they built their data lake on AWS. We have customers in the region that have built data lakes on AWS, and we are happy to also work with customers who have not started on the journey yet, but would like to begin. And we are happy to engage with you guys on that. A usual process that you follow when you build a data lake is something that I have on the screen now. So it's a multi-step process. You begin with identifying what are the data sets that you have. You figure out a way to ingest that data. You work on tools that will help you bring that data into the platform and store that data, process that data, catalog it, and then finally make it available for users to consume. But then the problem is, once you have done all of this, all of this is very manual. So you need to think about, how am I going to automate all of this? Is there something that I can do to make all of this much easier? So that's where AWS worked on like a service, and that is what we're going to talk about today. So our product teams did a research, and they did a survey, and we found out that data engineers and data scientists are spending a good amount of time on their day-to-day job trying to clean up data and do ETL. So this is stuff that is important, but it is not the most important thing that they are supposed to do in their day-to-day job. They would rather be spending time building models and building analytics models on top of the data than actually working with the infrastructure around it. So that's why we launched the service called Lake Formation in reInvent last year in 2018. Lake Formation is a service that allows you to build data lakes in a matter of clicks. And what you get is, you set up the ingestion, you set up the storage, you set up the security procedures around the storage, and then you say, how am I going to allow users to collaborate on the platform? And at the cherry on the top of it, it allows you to do monitoring and auditing of these, monitoring and access control around the data sets as well. So let's take a look at how do you actually start building a data lake using Lake Formation. The first thing that you do is set up an S3 bucket and tell the Lake Formation that this is the storage layer for the data lake, and you can register your existing S3 buckets, or you can create a new one. You can import existing data that you have within your bucket, or you can use something called blueprints, Lake Formation blueprints, to import the data. So we'll talk about blueprints in the next couple of slides. And once the data is brought in, you can use your usual ways to access the data using the API, SDK, AWS console, and whatever other tools that you have been using in the past. And this is how a usual flow of Lake Formation ingestion pipeline looks like. On the extreme left-hand side, you have data sources. So you have RDS data sources, which are a relational database service that we have. You can bring the data in from an RDBMS system in a single shot, or you can also do incremental loads into it. Once the data comes into the data lake, Lake Formation will store the data into S3. You can go in and specify the access control around it, and we have something called glue crawlers that allows you to auto-discover the data and create a catalog around it. So all of this is automated. The only manual step that you need to do is setting up your source and setting up the access control. Rest everything, all the way from data import to accessing of the data is automated. Let's take a look at what actually a blueprint is made of. So blueprints are templates. They are predefined templates that AWS is giving. As of today, we support blueprints for RDBMS systems. So if you're using an RDBMS database either on-prem or on AWS that can talk over JDBC, we can have Lake Formation ingest that data using a blueprint. Blueprints in the backend use glue workflows, which chain events together, and it uses the data catalog to store the metadata about your information. And then you have glue jobs that act as the data ingestion tools, and also act as where you'll do your ETL. And then you have your database connections and tables that are core structure to the to the Glue environment. And on top of that, we have monitoring capability that sits across all of this to give you the ability to monitor and see how things are going and how things are progressing. We also added with Lake Formation a new feature called ML Transform. So ML Transforms are our way to help you clean your data better. So one of the ML transforms that we have added is the ability to do data deduplication. So if you have records that are like you have duplicate records within your data sets, you can train your own machine learning model and tell it that this record is a duplicate of this. And then going forward, once the model is ready, you'll be able to plug it into your pipeline, and it will do automatic data cleaning for you. So it's a pretty cool feature. In the future, we'll be adding more transforms, but right now the one that we have is for data deduplication. So once the data lake is created using Lake Formation acts as a central place where the security happens. So it becomes a central place where all your access control is managed, all your the user management is done, and the metadata management is done. So let's take a look at how do you provide security features with Lake Formation. So what you see on the screen is on the top, the image that you see is actually showing the list of tables that I have. And once I click on the table and I say grant permissions, here on the image on the bottom, you can see that I've added 3 users there and I've given them access to create, delete, and alter tables. So this is how easy it is to do data lake security. So anybody who has built a data lake knows how difficult it is to do this in practice. The next challenge that we saw our customers facing was, hey, I've got one table, and I've got 2 set of users who want to access this table. But then I want to give one user access to everything and the other user access to only the limited set of data. And that is exactly what Lake Formation allows you to do. So it allows you to set column level permissions for every user. So user could be talking to Lake Formation, and Lake Formation will decide who has access to what. And you can control that and add that data governance bit in there. And Lake Formation has integration with Athena as well. So within the Lake Formation console, you can run the Athena queries as well. And we have the ability to audit and monitor things in real time. So if somebody changes a permission for a particular table, a new data set is added, all of that is available within the console for you to audit and take remediation actions. So I think enough of me talking now. So we should get into a demo. So let me show you an architecture that we have for the demo. So I've pre-recorded the demo for you guys. So what we are going to do is we have our MySQL database that I have. So it is an employee database. I'm going to bring that data into Lake Formation. And Lake Formation is going to crawl that data, import that data. And I'm going to access that data using Athena, which is our interactive querying tool. And we are going to have 2 users, HR user and the BI user, that will access this data. So HR user should be able to see salary information, and BI user should not be able to see salary information from the same table. So that is what we are trying to demonstrate. Team, can we have the video? So here I'm on my Lake Formation console. I clicked on Add Storage, and I put in my storage bucket name. What I'm specifying here is the role that my Lake Formation will be using to run this job. Next, I'll have to give access to Lake Formation to actually modify this bucket. So I'll go to Data Locations, and I'll grant permissions here. So I'll click on Grant Permissions. And here I'll specify my specify the name of the role. So I'll add myself, that is the admin user. So I'm admin in this account. So I'll add admin, and I'll also add the Lake Formation user here, the Lake Formation role here. So once Lake Formation role is added, and I add the S3 bucket name, Lake Formation and myself, that is admin, will be able to control that bucket and delegate access to other users within my data lake environment. So now this is done. Let's take a look at how I actually bring the data into the platform. So you can see that admin and Lake Formation role now have access to that S3 resource. So I'll go to data importers. So data importers are nothing but blueprints. So I'll click on add a data importer. And when I click on add on data importer, it will show me multiple blueprint options that are available. So there is a database snapshot option, which is basically go to the database, bring everything, put it back in. There is an incremental database option, blueprint, that allows me to go in there, bring everything, and then continuously replicate the data that is changing on the source. So this is what you'll be doing if you have a CDC kind of a use case, a change data capture kind of a use case. And then I've got CloudTrail as well. So here I've already got a database connection within my environment. So I'll just use the database connection that I have called EmployeeDB. So I'll choose EmployeeDB here and tell Lake Formation that bring everything that is sitting inside the employee schema. So I'll say employee/percentage. So percentage is basically a wildcard that allows me to bring in everything. So I'll say employee/percentage, and I don't want to exclude any tables because there's only one table in my database anyway. So here in the target, the import target, here I'm telling Lake Formation that which glue database should it update with this data. So here what I'm going to add is I'm going to create a new database in Lake Formation, and I'll call the database employee. And I'll add a description for it. So I'll just call it employee DB import from RDS. And I'll click on create database. So this will create my metadata, a database in my glue metadata store. So once this is done, I cannot directly go and put data into this database because I don't have access to this. So what I'll have to do now is grant access. So this actually shows you how much granular level of security Lake Formation provides out of the box. So I'm obviously adding myself, that is admin, and the Lake Formation role to be able to do all the operations. So I want myself to be able to delete the table, create the table, and also alter the table information. So I'll create. Now everything is set. I think I can go ahead and start importing the data. So admin and Lake Formation role both can create, drop, and alter information in this database. So here now I'll refresh this, and I should be able to see my employee database here. So the employee database is here. And I'll just add the S3 location where Lake Formation is going to dump the data into. So this will be my raw data lake. So this is the place where the initial data dump happens. A lot of people call it staging database, staging data lake. So whatever your nomenclature would be, this is where the initial set of data comes in. So to keep it clean, I just want to remove the raw part from there because it just creates a mess with my environment. So I'm just going to keep it to data and employee. And Parquet is the data format that we are using. Parquet is a columnar data format. It allows you to analyze data in a faster way. So it's a columnar data store. And because this is a bulk upload, I don't want to change the frequency. I'll just say run it on demand. Here I'm going to give a data importer name. So there's not much significance of what is the data importer name that you give. It's just a label for you to identify on the console and using the API. And the other important thing that you need to specify here is the IAM role. So IAM role will be the Lake Formation service role. So I'll be selecting the Lake Formation service role. The DPU information, that is the scaling unit for glue. So data processing unit, it's an optional parameter. So I'll not choose that, and I'll click on add importer. Once this is ready, and now you can see that it is creating. So if I click on actions, I'll not be able to start it. So I'll just have to wait for a couple of seconds for it to become available or in a ready mode, so that I can go and start the data import process. So I clicked on the database, I click on actions, click on the data importer, click on actions, start, and it starts the data import service. The next thing that it does is it creates a bunch of things in backend for you to actually import the data, crawl the data, and get the data into S3. So first thing that it does is it creates a glue crawler. So glue crawler is a tool within AWS Glue that allows you to go to your data source, catalog that, auto-discover that data, and catalog it into Glue metadata store. So here you can see that this crawler is running. So it created a crawler, and it has an automated name to it, and it shows the state is running. And it created a temporary database. You can see there with tilde, data lake import, and it's using the service. And you can see the data store here is my JDBC employee database that we put in the previous steps. Now this usually takes close to 40 seconds to a minute to run, and once that is done, it will be able to you should be able to see the tables created. The other things that it does is it creates a bunch of jobs in Glue. So these are PySpark jobs that Lake Formation has created for me, and each job has a function within the whole workflow. And all of this is tied together using a feature in Lake Formation in Glue called triggers. So you can see when I click on the trigger, it will show me a chain of events that are tagged together. So when job 0 completes, job 1 runs. When 1 finishes, 2 runs. So when all of this runs in one sequence is when my data importer job would be finished. Let's go back to our crawler and see what happened here. So if I keep refreshing this now, you'll see that the crawler would have updated the table. So now you can see on the right-hand side, it updated one table. So if I go to the if I go back to the Lake Formation page now, so if I go to the Lake Formation page now, it will actually show me the table that has been created for that particular crawler. So under databases, that's a temporary database where it actually updated it. So we'll open the temporary database, and when we click on View Tables, you can see that this is a staging database. So when I click on View Tables, it actually has the data in here, and you can see the metadata about this information about this table as well. So classification is MySQL because the data is coming in from MySQL. And those are some of the properties for my table, and these are the columns that is inside my database. So I never went to the database, I never logged into the database server. The Glue crawler did all of this for me. So this is what blueprints do for you. So next thing that we'll see is we go to jobs page back in Glue, and you can see that these jobs are running. So now the data import process has happened. So it was a two-step process. One, it creates a crawler which goes and discovers the data and puts that information into a Glue catalog. Then the Glue job runs that actually bringing the data in from the RDBMS system into S3 and storing it and showing it in my data lake. So here, if I go back to S3, so I should be able to see the files that have been that has landed here. So here I'm on my S3 console. I'm going a bit faster than my recording. So we click on data, we click on employee, and you should be able to see the table information here. So it says employees is the database, and the name of the table is also employees. And here I have the version 0 of my data lake that is already created. So this is my raw data. And if you can see, the data is added as in Parquet format. That is the one that I chose. That's the format that I chose when I created the data importer. Now I'll go back to the main database. I'm not going to the temporary database. I'm going to the main database, and I should be able to see the tables from here. So you can see there is a temporary table created and a main table created. If I click on the main table, this time you'll see the classification is Parquet, and the data location has changed to S3. It's not MySQL anymore. So the data is now sitting in S3. And there is a bunch of other properties that are available here that you can take a look when the recording is made available for you later. And if you scroll down, there's a bunch of there are a bunch of columns that were imported that will also be shown. So you can see that the source type is JDBC. So the data came in using a JDBC connection is what it is telling. And you still have all the information in there. So you have the department name, the employee ID, and the salary information, all of that information that has been imported for you. Next thing that we'll be doing is, and this is the most difficult part usually in a manual data lake creation process, is doing security around it. So take a look at how easy it is to actually do it with Lake Formation. I choose the database name, I choose the table name, and I say grant permission. So I should be able to grant permission to this particular table to a specific set of users with just a couple of clicks. So here I go in and add the demo HR user. And what I'll tell Lake Formation to do is give access to demo HR user for employee database to employees table. And columns, I say, give it access to everything except except blank. So when I do that, it says, I say, that's the wrong option, so I'll change that again. So I'll change that to all except excluded columns, and I say blank. So HR user will be able to access everything. So technically, it has access to star columns. So all the columns within the database, it will be able to access. And now I will add the permission for the BI user that we spoke about earlier. So I'm going to go to grant permissions again, and I'll select the BI user there. So we look for demo BI user, and here I'm choosing the employee database again. Choose the employee table, and here I will say has access to everything except these columns. So now I can filter out sensitive columns that I feel the BI user should not be able to see. So first of all, I don't want the person to identify who is the employee. So I remove the employee ID. I don't want to filter them out. I want to filter date of birth, and I want to filter out obviously the salary. So these are the columns that I'm interested in that they should not have access to. And then I say grant permission, and I say select and grant permission. So now you can see BI user has access to everything except those three columns, and they can run select statement on that particular table. Whereas with the HR user, they can run select star from the table, and it will work fine. Let's take a look at actually how does this work. We are going to use Athena to run two queries, one using the BI user and one using the HR user, and we'll see what is the difference that we'll get when we run a query like that. So this is my HR user. So you can see on the top right it says demo HR, and this is my BI user. So so this is the Athena console from where I'll be connecting to Lake Formation's catalog and bringing the data in and querying the data that I want to access. So here I'm querying department name, gender, count of department, and average salary. So what I'm running is give me a summary of average salary based on department for a specific gender within that company. And because this is using average of salary, the HR user has access to this. So this query should work fine. So when I click on run query, it will take a couple of seconds for the query to run, and it will show me that the query ran successfully. So we'll just wait for the query to finish. So the query has finished, and now I can see the salary information is available. So I can see that customer service team, the average salary for females is 67,000, whatever the number is, right? Whereas on the other hand, with the BI user, if I run the same query, so I just copy paste the query into the BI user, and when I run it, we'll see what happens. So it immediately fails, saying column employee salary is not available for this user to access. So that column itself is not visible for the user. So this is how you implement column level or attribute level security using Lake Formation for your data lakes in AWS. So I'm just going to get rid of that query, put in a new query without the salary information, and that should be able to run fine without any issues. So this query doesn't have any salary information. So when I run it, that query will run successfully, and I should be able to see the data. So there. So the query has run, and I think we are good. So with that demo, I wanted to basically show you what is the flow of building a data lake on AWS using Lake Formation. And one of the key things to notice, and this is what really excites me talking about this service to you guys, is this service comes with no charges. So you don't pay anything for Lake Formation itself. You pay for the services that it uses in the backend. So you pay for the data that it is storing in S3. You pay for any Glue jobs and crawlers that are running and catalog that it is using in Glue. Other than that, the service itself is pretty much free of charge. So I wanted to end the session with a couple of best practices. So we have always build systems that are decoupled, and you have the storage system, the processing system, and then use the storage layer as your decoupling layer. Use the right tools for the right job. Make sure you're using the tools that are built for purpose. So don't use a data warehouse to run your OLTP workloads, and don't use your MySQLs as your data warehouses. So you don't want to do that. And build your systems in a way that are good on your pocket and go easy on the CFO when they are signing the check. So make sure that you're cost conscious, and if you have issues around how do you optimize for cost, feel free to reach out to anybody from your AWS team, and we'll be happy to help you guys with the cost optimization bit. And always talk to your consumer groups within the company to make sure that you understand the requirements before you start building out the lake. And these are some of the partners in the region that have done some amazing work with data warehouses, with data lakes on AWS. And all of those partners have worked with our customers in the region to help them build the data platforms on AWS. So guys, that's all I have for you today. Please take your time to fill the feedback. And thank you very much for spending time with us today. And you guys have a good evening.